Why do some people look almost the same at 40 as they did at 30, while others seem visibly worn by their mid-30s? Part of the answer lies in genetics, part lies in lifestyle, but a significant part lies in emotional regulation, specifically how often and how intensely a person activates their stress response. Let us begin with what happens inside the body during stress. When you perceive a threat, whether it is a real physical danger or an argument over text, your brain activates the hypothalamic pituitary adrenal axis. This triggers the release of cortisol and adrenaline. Heart rate increases, blood pressure rises, glucose is released into the bloodstream, muscles tense, attention narrows. This reaction is efficient for short-term survival. If a car suddenly swerves towards you, this system helps you react quickly. The problem emerges when this reaction activates for minor, frequent, non-life-threatening events. A delayed reply, a small criticism, traffic, academic pressure, social comparison on social media. If these situations repeatedly trigger strong emotional reactions, cortisol levels remain elevated for longer portions of the day. Cortisol in moderate bursts is useful. Chronically elevated cortisol alters cellular processes. It increases inflammation and reduces collagen production in the skin. Collagen maintains skin elasticity and firmness. Reduced collagen accelerates wrinkle formation and sagging. Inflammation also affects internal tissues. It places continuous strain on organs. Over years, low-grade chronic inflammation contributes to biological aging. Calm individuals still encounter stressors. The difference lies in amplitude and duration. Their emotional spikes are smaller, and their recovery is faster. Shorter exposure to elevated cortisol reduces cumulative damage. Now consider sleep in more detail. When someone remains mentally agitated at night, the sympathetic nervous system stays partially active. Thoughts loop. Muscles remain subtly tense. Even if the person falls asleep, deep sleep stages may be shortened. Deep sleep is when tissue repair peaks. Growth hormone is released. The brain clears metabolic waste products. Immune regulation strengthens. If deep sleep is consistently reduced, nightly repair becomes incomplete. Incomplete repair accumulates small deficits. Over time, these deficits show up as fatigue, dull skin, slower recovery from exercise, and cognitive decline. Calm individuals transition into parasympathetic dominance more easily at night. Their heart rate decreases, breathing slows, muscles release tension. This physiological shift supports deeper sleep cycles and more complete restoration. Cardiovascular health also plays a central role in aging. Frequent emotional surges create repeated spikes in blood pressure. Each spike exerts mechanical force on artery walls. Arteries are elastic, yet elasticity decreases when strain is constant. Over decades, repeated pressure contributes to arterial stiffening. Stiffer arteries correlate with higher cardiovascular age. Cardiovascular age often differs from chronological age. Calm individuals experience fewer extreme spikes. Their cardiovascular system remains within moderate ranges for longer periods. Reduced mechanical stress preserves vascular elasticity. Now examine the brain structurally. Chronic stress affects the hippocampus, which supports memory consolidation and emotional regulation. Prolonged exposure to high cortisol levels correlates with reduced hippocampal volume. Reduced hippocampal volume influences memory performance and emotional stability. Emotional instability can create further stress reactivity, forming a reinforcing loop. The prefrontal cortex, responsible for impulse control and rational decision-making, also functions more effectively when stress is regulated. When stress dominates, prefrontal activity decreases while the amygdala becomes more reactive. Calm individuals maintain stronger prefrontal regulation during challenges. This regulation prevents exaggerated emotional responses and shortens stress duration. Telomeres provide another biological indicator. Telomeres are protective caps at the ends of chromosomes. They shorten with each cell division. Chronic stress correlates with accelerated telomere shortening. Shorter telomeres associate with increased biological aging and disease risk. Lower chronic stress exposure associates with slower telomere shortening. This difference emerges over years, not days, because cellular aging reflects cumulative biochemical exposure. Now, move beyond biology into behavior. A reactive person often copes with stress through short-term relief behaviors. Late-night scrolling, excessive caffeine, emotional eating, alcohol use, irregular sleep patterns. Each of these behaviors influences metabolic health. Irregular sleep disrupts hormonal balance. Excessive sugar increases glycation, which damages collagen. Alcohol increases oxidative stress. Poor routines reduce exercise consistency. Calm individuals do not eliminate stress entirely, yet their lower reactivity reduces the urge for compensatory habits. Stable mood supports stable routines. Stable routines protect long-term health markers. There is also a muscular component to aging. Facial expressions reflect emotional states. Chronic worry tightens the brow. Persistent frustration tightens the jaw. Subtle tension becomes habitual. Muscles that contract repeatedly form patterns. Skin folds along those patterns. Over years, these microcontractions contribute to visible lines. Calm individuals display fewer prolonged tension expressions. Their facial musculature rests more frequently. Reduced repetitive contraction slightly slows visible aging. Posture also reflects emotional tone. Stress often shortens breathing and rounds the shoulders. Shallow breathing reduces oxygen exchange efficiency. Chronic shallow breathing increases sympathetic activation. This posture and breathing pattern reinforce each other. Calm individuals typically maintain slower, deeper breathing. Deeper breathing stimulates the vagus nerve. Vagal activation enhances parasympathetic tone. Strong parasympathetic tone improves heart rate variability, digestion, and immune regulation. Heart rate variability is a marker of resilience. Higher variability often correlates with better stress recovery and lower biological age. Now, consider cognitive interpretation. Two individuals experience the same event, such as receiving critical feedback. One interprets it as a threat to identity and future success. The emotional intensity increases. Stress hormones rise significantly. The other interprets it as information for improvement. Emotional intensity rises moderately and then decreases quickly. The difference lies in cognitive framing. Framing determines physiological output because the brain reacts to perceived meaning, not objective facts alone. Thousands of daily interpretations accumulate into long-term physiological patterns. Recovery speed matters as much as activation strength. Stress itself is unavoidable. The body is designed to activate. Aging accelerates when activation remains unresolved. If stress chemistry persists for hours after a minor trigger, the body spends more time in repair-suppressed mode. Calm individuals close stress cycles faster. They feel the activation, process it, and return to baseline. Imagine two people lifting moderate weights daily. One rests sufficiently between sessions. The other lifts again before recovery completes. The second accumulates micro-injuries faster. Stress works similarly at the cellular level. There is also an identity dimension. Frequent emotional volatility destabilizes self-concept. When internal states fluctuate dramatically, decision-making becomes inconsistent. Inconsistent decisions affect career, relationships, and health behaviors. Stable emotional regulation supports coherent identity. Coherence reduces cognitive load. Reduced cognitive load conserves mental energy over decades. Chronic anxiety also narrows attentional focus. Narrow focus reduces openness to experience. Reduced openness can limit social engagement and intellectual growth. Social isolation correlates with faster aging markers, both mentally and physically. Calm individuals often sustain longer, steadier social connections because they respond rather than react impulsively. Strong social bonds correlate with longevity and better immune function. All these small differences compound. Aging reflects accumulated exposure to chemistry, behavior, posture, sleep quality, cognitive framing, and social stability. Calm individuals produce slightly different patterns in each domain. Over years, slight differences become visible. Cultivating calmness is practical rather than mystical. Begin with physiological regulation. Practice slow nasal breathing, 5 seconds inhale and 5 seconds exhale for 5 minutes daily. This strengthens parasympathetic tone. Introduce a pause before reacting to stress. Count 3 breaths before responding to criticism or conflict. The pause allows prefrontal regions to re-engage. Reduce rumination by externalizing concerns. Write problems on paper and outline possible actions. Structured thinking prevents prolonged emotional looping. Establish consistent sleep timing. Dim lights before bed. Avoid high-stimulation content late at night. Regular sleep strengthens emotional resilience. Engage in moderate physical exercise. Exercise reduces baseline inflammation and improves mood regulation. Over time, these habits train your nervous system to recover efficiently. Aging cannot be stopped, yet its pace is influenced by daily internal chemistry. Calmness alters that chemistry. Observe your own reactivity. Notice how long your body remains tense after minor stress. Notice your breathing pattern during inconvenience. Small adjustments repeated consistently influence long-term trajectory. Calm people do not avoid difficulty. They process it without excessive amplification. That difference in amplification changes how long stress chemistry circulates in the body. Years are measured chronologically. Biological wear is measured chemically. Emotional regulation shapes that chemistry every single day. Now let us continue deeper, because the visible differences between calm and chronically reactive people are only the surface of a much longer internal story. There is a concept in biology called allostatic load. Allostasis refers to the body's ability to achieve stability through change. When something stressful happens, your body changes heart rate, hormones, blood pressure, and attention in order to adapt. Allostatic load is the cumulative wear and tear from repeated adaptation. If you activate the stress response 5 times a day and return to baseline quickly, the load remains manageable. If you activate it 20 times a day and stay activated for long periods, the load increases significantly. This load is invisible in the short term. You do not wake up one morning and see a dramatic shift. Instead, the load accumulates slowly across years. Calm individuals carry lower allostatic load because their baseline is steadier. Their system shifts when necessary and then settles again. Chronic reactors stay partially activated even in neutral environments. Think about an engine that idles at high RPM all day long. Even when the car is parked, the engine is revving slightly. That engine will wear faster than one that returns to a low idle when not moving. The human nervous system functions similarly. Now, consider metabolism. Chronic stress increases glucose availability in the bloodstream. In short bursts, this prepares muscles for action. When stress becomes frequent and physical movement does not follow, glucose remains elevated more often than necessary. Over time, frequent elevations can contribute to insulin resistance. Insulin resistance accelerates metabolic aging and increases the risk of chronic disease. Calm individuals experience fewer unnecessary glucose spikes because their stress activation aligns more closely with real physical demands. Hormonal balance also shifts under chronic stress. Cortisol interacts with testosterone, estrogen, and thyroid hormones. Persistent stress can suppress reproductive hormones and disrupt thyroid function. Thyroid hormones regulate metabolic rate. Dysregulation affects energy, weight, skin texture, and hair quality. Subtle hormonal imbalances over years influence visible aging patterns. There is also the immune system. Acute stress temporarily enhances immune function. Chronic stress suppresses it. Suppressed immunity increases vulnerability to infections and slows healing. Slow healing means prolonged inflammation after minor injuries. Inflammation, when unresolved, contributes to tissue breakdown. Calm individuals experience shorter immune suppression phases because their stress cycles close more efficiently. Now move into the mental dimension more deeply. Calmness is strongly linked to attentional stability. When someone reacts intensely to every stimulus, their attention is constantly redirected outward. External events control internal states. This external control reduces perceived agency. Reduced agency increases anxiety. Anxiety increases vigilance. Vigilance maintains sympathetic activation. Calm individuals tend to anchor attention internally. They notice stimuli, but they do not allow every stimulus to dictate their state. This internal anchoring reduces unnecessary vigilance. Chronic vigilance exhausts cognitive resources. Exhaustion affects memory consolidation and creative thinking. Creativity and learning keep neural networks active and flexible. Neural flexibility correlates with cognitive longevity. A brain constantly scanning for threat allocates fewer resources to exploration and integration. There is also a time perception element. Reactive individuals often live in future-oriented worry or past-oriented rumination. This mental time travel consumes cognitive bandwidth. The brain processes imagined threats similarly to real ones. Heart rate and stress hormones still shift. Calm individuals tend to process events more in present context. They evaluate what is actionable and what is outside control. This filtering reduces unnecessary mental simulations. Fewer simulations mean fewer stress cycles. Socially, emotional stability affects relationships. High reactivity can create conflict escalation. Conflict escalations strain relationships. Chronic relational strain is a major long-term stressor. Calm individuals de-escalate more often. De-escalation preserves relational stability. Strong relationships correlate strongly with longevity and slower cognitive decline. Over decades, relational stability becomes a protective factor against both physical and mental aging. Now consider posture and movement in more detail. Stress frequently produces subtle muscular guarding. Shoulders elevate. Neck tightens. Jaw clenches. Even when sitting quietly, muscles remain partially contracted. Chronic contraction restricts blood flow slightly and increases muscular fatigue. Reduced blood flow impairs nutrient delivery to tissues. Calm states encourage muscular release. Released muscles allow better circulation. Better circulation supports tissue health. Breathing patterns also shift aging trajectories. Shallow chest breathing activates sympathetic dominance. Slow, diaphragmatic breathing activates parasympathetic tone. Parasympathetic tone supports digestion and nutrient absorption. Nutrient absorption directly affects cellular repair because cells require amino acids, vitamins, and minerals to rebuild. If digestion remains impaired by chronic stress, repair quality declines gradually. There is also the matter of oxidative stress. Chronic emotional turbulence increases production of reactive oxygen species. These molecules damage cellular structures, including DNA and mitochondria. Mitochondria generate cellular energy. Damaged mitochondria reduce energy efficiency. Reduced energy efficiency accelerates cellular aging. Calm states reduce unnecessary oxidative bursts by limiting prolonged stress chemistry. Over a decade, slight differences in oxidative load produce noticeable differences in vitality. Another dimension is decision fatigue. Reactive individuals often make impulsive decisions under emotional pressure. Impulsive decisions can produce lifestyle instability. Lifestyle instability affects sleep timing, diet consistency, and exercise habits. Calm individuals often pause before decisions. That pause improves decision quality. Higher quality decisions compound positively over time. Compounding works both directions. Small physiological advantages, repeated daily, produce large differences over decades. Small physiological disadvantages, repeated daily, also compound. It is important to clarify that calmness does not mean emotional suppression. Suppression stores stress internally and may increase physiological load. Healthy calmness involves processing emotion without amplification. You experience the feeling, understand it, and allow it to resolve. Resolution shortens stress duration. Imagine two people experiencing the same insult. One replays it mentally for 3 days. Each replay triggers another small stress response. The other reflects once, extracts meaning, and moves forward. Stress activation lasts minutes instead of days. Multiply that difference across years. Biological aging reflects repeated chemical exposure. Mental aging reflects repeated cognitive patterns. Calm individuals generate fewer unnecessary chemical storms and fewer unnecessary cognitive loops. You can cultivate this deliberately. Increase awareness of micro-reactions. Notice when your jaw tightens. Notice when your breathing becomes shallow. These signals indicate early stress activation. Interrupt early with slow breathing. 5 slow breaths can reduce sympathetic intensity. Practice cognitive labeling. Instead of merging with emotion, name it. Labeling recruits prefrontal areas and reduces amygdala reactivity. Schedule deliberate recovery periods during the day. Short walks without digital input allow your nervous system to settle. Strengthen physical resilience with regular exercise and adequate protein intake to support tissue repair. Reduce stimulants that exaggerate stress responses, such as excessive caffeine. Over months, these adjustments change baseline physiology. Calmness then becomes a trait rather than a temporary state. Aging is not only the passage of time. It is the accumulation of internal patterns. If those patterns involve constant tension, constant vigilance, and constant amplification, wear accelerates. If those patterns involve regulation, recovery, and proportionate response, wear slows. The difference may appear subtle in 1 year. Across 20 years, it becomes visible. Your nervous system writes your aging trajectory daily. The tone at which you respond to ordinary life influences how quickly that trajectory unfolds. If this made you think about how you handle stress in your own life, write in the comments what usually triggers your strongest reactions and how long it takes you to calm down. And if you want to understand how to build that kind of emotional control step by step, watch the next video where we break down practical methods for training a calmer nervous system.